The physics of softball. According to Newton's first law, anything at rest tends to stay at rest, and anything in motion tends to stay in motion, unless acted upon by another force. This applies to softball in many ways. For example, a ball that is hit will continue moving forward direction until interrupted by the friction of the ground or until a player catches the ball. When a ball is hit on the ground, the force of friction slows it down. The force of the ground pushes up, and the force of earth pushes down. Friction can happen when dirt slows a ball on the ground or when air slows a ball that is being hit or thrown. This is beneficial because the friction slows the ball down, making it easier to stop. Ouchie!
Newton's second law states that when one body exerts a force on a second body, the second body simultaneously exerts a force in equal magnitude and opposite in direction on the first body. This can apply to finding the acceleration or the force of hitting a softball because we have a bat, one body, exerting a force onto the ball, which is the second body, and sending the ball into the opposite direction.
When a player hits a softball, it is accelerated in the direction of the outfield. The bat exerts about 650 newtons of force in the ball, which weighs approximately 0.2 kilograms. Plugged into the equation F equals ma, we get an acceleration of 3,250 meters per second squared. The two forces acting on the ball while it is being hit is the force of the earth in the ball and the force of the bat on the ball. Some factors that could affect the constant acceleration are air resistance, earth, and the bat on the ball.
Professional softball players wear cleats that have metal spikes on the bottom. The spikes dig into the dirt as they run and creates a pressure that helps them to not slip and to get a better jump. The pressure of the cleats can be found by using the equation pressure equals force divided by area. After plugging in our values, we come up with a total pressure of 58.8 pascals, or newtons per centimeter. As the player runs down the base path, she is moving at a constant velocity. She runs at a speed of 4.35 meters per second for about 18 meters. Plugging these numbers into the equation, final position equals velocity times time plus initial position, we get a constant velocity of 4.2 meters per second. The forces acting on the runner is earth pushing up, air resistance, and the ground acting upwards and pushing the player forward. The wind power could affect the overall speed of the runner, so with more air resistance, the runner needs more force to go the same speed. Baseball is a sport very similar to softball, but there are some differences that change the game dramatically. For example, a baseball is a few inches smaller than a softball and a few ounces lighter. If we compare accelerations, the lighter baseball will travel much farther, much faster, and at a higher acceleration. This also makes for longer base paths in baseball and a farther home run fence since the ball travels so far and so quick.
Would you say that leg power has a big impact on the power of your swing and the velocity of the ball you hit?
Yes, because you generate a lot of power through the bottom of your body. Your legs do produce the power. I think you start with your feet about shoulder width apart and then with your knees bent, and as the ball is being pitched, you load up, you push off your back foot, moving towards the pitcher, and that motion helps you generate that power through your legs.